So before we get into exactly what we're going to do, I want to start with just a few assumptions and just a few things to keep in mind. So the objective here, and this is saying in words what I kind of put on the prior slides, we want to figure out which portfolios, which combination of grain machines, grocery stores, etc., give us the highest expected return and for our level of risk. So we may not want to be exposed at all to the internet startup because we're very risk averse, and we may want a bunch of grocery store, or we may have some other preference for risk. The goal is to figure out how to select a portfolio that aligns with the investor's preferences. And just to give you an idea, the risk is measured by the standard deviation. And so we're going to calculate variance, and then we're going to calculate standard deviation, and that's what we're going to use to make all of these decisions. And the other thing that we want to kind of talk about is past returns. They're helpful for figuring out kind of general risk, but you can't use past expected returns to project future returns. So imagine, for instance, that you had taken Amazon returns in the early 2000s. Amazon has done really, really well, but as it's gotten bigger, it's gotten harder and harder for them to make the same return. So another example would be like Berkshire Hathaway. Berkshire Hathaway did really, really well for a very long time, but Warren Buffett told everybody these returns are not sustainable. We can literally not make these returns forever. And so he has sort of defied expectations in a lot of ways, but the idea is that as a company is growing, they may make 20, 30, 100% gains in certain years, but when they finally get to a certain size, they can't grow that much anymore. And so they kind of reach like a steady state where they have very low growth. So just remember, past returns are not indicative of future performance. The other thing to note, it's kind of a passing thing, but if you ever get like a mutual fund statement, the mutual fund statement will say on it, past returns not indicative of future returns. And a lot of that is legal. Like they can't say, hey, we made 50% last year, we're going to make that for the rest of all time. A, that wouldn't make sense because you can't make 50% return forever. But B, it's a legal issue because they can't use that in advertising. Anyway, just something to keep in mind. Okay, so when we talk about expected returns, usually what that looks like is we may have, and people simplify this, but think about the future of the world, so to speak. There's a couple different states of the world that one might imagine, and one state would be climate change is really, really bad. Another state is we figure out climate change, we create some new industrial revolution or computer revolution, and everybody flies around in jet cars. So in that case, there's two options. One option is the awesome case where everything goes well, and one option is the really, really crummy case and everything goes poorly. And so when we're calculating expected returns, what we're doing is taking the probability of the awesome case times the return that we would get in that awesome case, plus the probability of of the crummy case times the expected return in that situation. So in words, we are going to take probability times return and sum them together. We'll see that in a second. All right, variance and standard deviation. We went over this the last time we had a class, but let's just go over it again. So the intuition is think about the regular variance that we talked about before. Variance is how much a return varies from year to year. So the stock may have a large variance, which means that it bounces around a lot. There's a lot of noise. We don't know what's going on. A low variance means it's very, very predictable and common. There's not a whole lot of change from year to year. And let's see. The other intuition is that you take the probability of each of these different events occurring and get the deviation from the mean and square it. And so what we're going to do in a second is say, well, the deviation from the mean is small here, but the probability that this happens is very large, and we'll weight that. And then once we're done, we get the square root of the variance to do the standard deviation. So when you look at these problems, and we'll do one in a second, there's a sort of a step that we're going to go through it. So we're going to calculate the expected return for the assets. We're going to calculate the variance and the standard deviation. We will calculate the covariance between these assets. We haven't really talked about that, but the covariance is like the correlation. It's how they vary relative to each other. We're going to use those to calculate variance and covariance matrices. And actually, let me add something here. Once we get that, we're going to calculate expected return, and we are also going to calculate expected standard deviation. And then finally, this is kind of a joke, get a fancy internship at a quant fund. Lots of quant funds use variants of CAPM. CAPM is like the workhorse model for the industry. So if this is something that you're interested in doing, then getting a fancy internship at the quant fund is something that you would want to focus on this presentation to do. Let's see. Yeah, so this is a restatement of what I'm saying. To calculate the expected return on a portfolio, you're going to weight all of the different potential worlds. So 50% chance of good world plus 50% chance of bad world times whatever the returns are for those. We're going to get a variance based on a similar methodology. And then one thing that we haven't talked about is the weights. So the weight of the portfolio, we're going to say, let's just scroll back up to this. We're going to calculate variances and covariances for these and correlations. We'll talk about that in a second. But we're also going to say that we're going to invest a specific weight in these. And once we do that, we can calculate the expected return for the portfolio. Okay, so these are some quick formulas, and then we'll talk about an example. So the covariance is the sum of the probabilities times the deviation from the mean for asset A, that should be A, and times the deviation from the mean for asset B. The correlation is exactly that. Let me fix that. Divided by the standard deviation for both of those. And again, we'll talk about this, but let me just give you some intuition. The correlation is one of the most helpful ideas in finance, and really in life in general. So when you do the correlation, because of the way it works, because when you divide by the standard deviation, and you have this deviation from the mean, you end up with a number that's between -1 and +1. If you do not have a number that is between -1 and +1 when you calculate the correlation, you have done something wrong. So the correlation of -1 means that things are inversely correlated. They move in the opposite direction. So if one goes up, the other one goes down. A correlation of 1 means they move in the same direction, so both go up at the same time. Uncorrelated means there's no discernible relationship. We don't really know what the relationship between these two variables is. Let me give you an example of perfectly correlated. So perfectly correlated would be like ice cream sales on, well, it would be pretty closely correlated. Ice cream sales on a hot day at the beach. The hotter it is, the more ice cream you're going to sell. If it's freezing outside, you're not going to sell any ice cream because nobody's going to be outside buying ice cream. Similarly, inversely correlated would be things that just move in the complete opposite direction. And I'm trying to think of an example off the top of my head, and it's not going to come to me, but, you know, along the weather format, like you're not going to sell, the sales of umbrellas are going to be inversely correlated with like weather temperatures or something. So when umbrella sales are up, the lack of rain is going to be down or something like that. That's not a very good example. But anyway, the point is that they move in the opposite direction. And a lot of assets are fairly correlated. And that's one of the problems that we've had in the market in general. So I forget what the market number is, but it's somewhere in like the 0.56 range. And it basically says like when something bad happens in the market, everyone tends to suffer from it. And there's like a saying that says when the US catches a cold, everybody else gets the flu or something similar to that. There's like less PC versions of that. But But the idea is that it's like what happens here is correlated with what happens in the rest of the world. And so therefore assets that are in the US stock market that are highly correlated with each other tend to move in the same direction. And that is a problem if you want to diversify your assets, which is our goal here. Like the main goal of this entire process is to say there is some gain from me not just buying the grocery store or not just buying the internet startup. If I mix these together, then I'm better off. But the problem is, if a bad state of the world occurs and all of these are down, then we have the exact same problem that we started with, which is that we have one asset, it doesn't protect us in down states of the world. So anyway, that's what correlation is, and it's important to think about it for our class and just for life in general.